Hello, everybody. Welcome to ExpoLab Blockchain Speaker Series. Today, it's my great pleasure to have Mohan join us. And this is also part of the Distinguished Lecture Series at UC Davis in our Computer Science Department. And so just a few words about Mohan as well. Of course, he's an ACM Fellow and IEEE Fellow and IBM Fellow. So he has the fellowship across the board. And some of his work, I'm just going to focus on one. The one piece of work, the Aries Protocol, and that's the foundation of pretty much recovery in any relational or non-relational database system. So the work that he did back in the 90s and in the 80s has become the standard definition of how you do recovery. And any system that come out, even the recent ones, they all rely on the guarantee that the Aries write-ahead login provides. So the fundamental to the success of relational system. And from my own personal experience, I had a pleasure when I was at TJ Watson and Mohan there was at Almaden. So we had a lot of interaction. He was one of my mentor during my 4 years at IBM. And the one thing that I really learned from him, and I think this is really good for the student, is that anytime he would go on and says, okay, I have this great idea, he would say, well, what is the effect of this idea on the entire system? And he would list all the different components that could be affected. Some of these components I didn't even know exist, let alone knowing there's any implication on it. And so you give an idea, he breaks it on into 10,000 pieces, and he tells you exactly what is going to be the overall effect of it. So the lesson is that the idea is good, but how does it affect? Sort of stepping back and be able to understand from the system, especially in the system research, how is it going to affect the overall system? And what I've seen in the 4 years that I was IBM, nothing will ship out of the door unless it had the stamp. So unless Mohan stamped it, nothing would go out of the door. And those stamps would require a lot of meetings and a lot of convincing to do. So, and it's great. It's been sort of a great learning experience. And each of them felt like a PhD defense. And imagine that doing that 3 times a week and for 4 years, and the learning which comes out of it is just invaluable. So without further ado, again, it's a great pleasure to have Mohan today with us. And so please take it away.
Okay, thank you so much for that wonderful introduction. And it's a great pleasure for me to be able to do this at least, although I would have highly preferred being there in person and doing it. And it's so sad that even though I live in the Bay Area, I haven't been in your campus in decades. And I've never given a formal talk, as far as I can recall, in the almost 39 years now I've lived in Silicon Valley. I was there once for my niece's graduation ceremony, but one of my IIT classmates is also there, Prem Devandu. He is my classmate, even from high school, believe it or not just college. In any case, so let me start sharing. Let's see. I got out of the sharing mode earlier. Okay, so I think we are okay, right? I'm going into the, yeah, okay. So this presentation, I posted the slides a little while ago, and the URL is also here. It's in the chat session. It's also in my Facebook and LinkedIn post and all that. I gave a version of this talk just about a year ago as the SIGMOD keynote in Amsterdam. So the URL, I mean, the QR code on the left is the 8-page paper that I wrote as part of that keynote. And you'll find lots of references there with links to the online version of paper and so on. So that's this paper. And then the video is also there and slides are also available. This right side QR code is for this page. And sadly, I just discovered a few days ago, Facebook is stopping supporting what they call the notes feature. And this is actually a Facebook note when you expand the URL. And so in the future, after October 31st, I can't edit that thing. It will still exist, but it cannot be edited. So I have to now find a new place to host all that and keep continuing to edit. But there you'll see lots of videos of talks and interviews and all that being linked. And so the reason I'm saying all this is because if I don't get around to discussing certain things today, I'm sure that I won't get around to discussing everything I might have to say. If you are interested in exploring more some of the things, you will find lots of other material that you can go look at via this link. And also, what you will find is that even the presentation material that I've posted at this URL, it has a lot more slides than what I'll actually be showing. So if you get the PowerPoint deck and you see it in the slideshow mode, you'll see the slides that I'm hoping to show. But if you go into edit mode, you'll see even more slides which are hidden in the version that you will see when you are in the slideshow mode. So this is the set of things that I thought, broadly speaking, I'll touch upon. Of course, this talk I've given in 14 countries in many kinds of venues. So from people who are not even technical people to hardcore technical people like you people, to some people in between, database people, non-database people, computer science, non-computer science, all sorts of people like that. So it tries to sort of have something in it for everybody. But that doesn't mean that it's all too high level. There is nitty-gritty stuff also. So depending on what interests you and so on, you might want to go dig more into certain aspects. And you can do that by looking at the extended version of the slide deck, or by going and listening to even my Sigmod talk and so on. Because every time I give the talk, even if the slide deck is the same slides are being shown, there's no guarantee that I say exactly the same thing. So I'll go off on some topic deep down in one presentation and do something else in another presentation and so on. So as I said in my abstract, I'm going to concentrate pretty much only on the permission blockchains. But in case somebody is there, since this has been announced as a general talk, I have lots of problems with the permissionless or the public blockchains for a variety of reasons. This whole notion of reward and hype about, we'll provide trust in a completely trustless environment. Lots of those things are, in my opinion, bogus claims, and also the awful performance, and also the whole notion of greed that has been introduced by making people have some control over which transactions get included in a block and things like that. And also this wasting energy and calling it mining and thinking that somehow guarantees a lot of trust and this and that. And also, then generating money by wasting energy and making it appear as if that money, the cryptocurrency by itself, has some any value behind it. Lots of these things have led to illegal activities being promoted. The whole notion of people in an anonymous way or pseudo-anonymous way being able to willy-nilly come and go into this public blockchain network with nobody knowing at any given time who's around and so on, and people hiding behind these anonymous ways of doing business. But of course, because it happened about 10 years ago and Bitcoin took off for a variety of reasons, not all of which is practical reasons, but more because it became like a way to crank out papers, or even in Silicon Valley companies, and all sorts of shady things have also happened with the notion of ICOs and so on. But it brought together many ideas. Not everything that was done in Bitcoin was completely brand new. And there are hidden slides which go into some of those things. But it also led to everything being visible to people and such. So it was in many ways counter to the notions like GDPR and such, which have come into force more recently, which try to limit who gets to see what and things like that. And also, all the privacy kinds of things that people should have worried about, didn't worry about as much. And also protecting intellectual property or even trade secrets or things happening in a business. A lot of those things will be better handled in a permission network where for a particular purpose, you have a network of people coming together because they have a business reason to be part of that network. Not just because somebody has some compute power available, they are twiddling their thumb and they want to get involved, like as a miner in the case of public blockchain. But here, it's like traditional workflow management, business process, that kind of situation where there are different people playing different roles, different organizations playing different roles, and they have a business purpose, which is a business process, which involves assets. And so in that context, people by definition have to reveal their identity and, based on their role in the organization and so on, they'll be permitted to do certain things or not permitted to do certain things and so on. This is traditional databases with authentication, authorization, and that sort of thing, right? Because only the people who have a need to be there are allowed to be part of the network. Scalability and all that is improved, performance is improved, controlled information sharing happens. So is the case that in the public blockchain, because of this game kind of manner in which the decision is made as to who gets to add a new block of transactions to the existing chain of blocks of transactions, it turns out the proof of work and such permit even more than one person to simultaneously win that competition. And as a result, there can be what used to be a linear chain suddenly becoming a branch chain and alternate paths coming into the picture and so on. But typically in a permission network, they don't permit that. And as a result, it's more predictable. And as a result, you don't have the kind of nonsense in the public one, which results in 10 minutes and such response times, because when there are alternate chains, they wait for a bit longer before they declare, based on some criteria, that the longest chain is considered to a 1 and the other chains are essentially consisting now of loser transactions. So because of such things also, that performance sucks. Not only is it bad, like 7 transactions per second, but even a single transaction outcome might take 10 minutes to be determined. And this is at a time when in traditional transaction processing, what used to be a sub-second response kind of requirement 35 years ago and so on, has become like now millisecond kind of requirements. So it's in that sense also very counter to what the traditional transaction processing kind of arena has evolved to, compared to even when TPC benchmarks and such, especially for the OLTP arena, got defined 35 years ago. And also this notion of transactions offering certain fees and that playing a role in which transactions get picked to be included in a block. All those sorts of things are completely counter to how traditional transaction processing systems, based on priorities of users who are issuing transactions and such, based on scheduling algorithms that have various goals in mind, determine at any given time what transactions get processed. And so in that sense also, I consider these newfangled ways of deciding what transactions should be picked up for quote unquote execution is counter to, and also not in my opinion, a good way or something that brings some benefits kind of way being done in the public blockchain. The other point is that a lot of that proof of work and so on is there because you first create a problem and then you bend over backwards to deal with that problem, which is you let random people come in without knowing their antecedents and all that. Then you say, oh shucks, these guys, because we don't know anything about them or know very little about them, they might do something really bad and screw us. So let's now waste a lot of energy, this, that, and then make things become ultra expensive to accomplish, that notion of people misbehaving is a lot less of a problem in a permission network where people's identities are known. And this is like real world, right? How do you decide, which plumber to employ in your house? You base it on reputation, this, that, what some people have said about this person on Facebook, this, that, or for companies, you could contact the Better Business Bureau and things like that, right? So in many such ways, while, yeah, people can still try to cheat you and things like that, it's less of a problem than in a public blockchain. So for such reasons also, I believe that the overemphasis that's being placed on inventing all sorts of consensus protocols is, I think, in many ways barking up the wrong tree, because you create unnecessary problems for yourself, and then you waste a lot of resources and reduce throughput and increase response time and such by going with these complicated protocols. And I'm a guy who has done a lot of complicated stuff, but still, I would rather work on things which have some practical value that might still be, requiring solving all sorts of hairy problems, but just solving hairy problems with the end result not being such an exciting practical thing, I have a lot of problem with. So in that sense, I would rather let you think of, as I said before, an environment where there is something of great use being put to with the network you are building and so on. So take a practical example like what you see here, multiple organizations working together, banks and corporate clients and third-party services and so on. So you have a network that represents the set of entities and what they are doing in a particular context. And so the business network connects businesses as well as people. I hate this, normal discussion where they say, "Oh, private blockchains are only for the enterprise environment." Give me a break. It can involve also, B2C, even C2C, but where people are playing certain roles. There might also be some organizations involved in this mix, but it's not like it's only companies dealing with companies. It can also be government to citizens kind of environment. So in general, what that means is that there are certain assets that are flowing across this network. The assets could be purely logical items like, music recordings or videos or whatever, or it could be physical goods that are being exchanged. The physical goods could change ownership or could undergo state changes. A diamond in its raw form is mined, and then you polish it. That's a state change. And then you split it into smaller diamonds, and then you sell this in bulk, sell it in retail. Now ownership transfers are happening and so on. So the transactions that you are performing in such a network are causing these sorts of ownership changes or state changes. And the smart contracts are nothing but really at their core rules of engagement amongst the different participants in this kind of a network that are very well spelled out and more rigorous than what traditional business process systems and workflow systems have done, where there was a lot more ad hocism. Different participants had their own programs and databases in which they recorded things. And so there was no single source of truth and things like that. And so there could be more misunderstandings and all that. In this context, the ledger is just keeping track of the different transactions that have been executed in a way that it's harder for people to go after the fact, change the history. But this doesn't mean that the databases that are used in this kind of a context by themselves are append-only database or anything. The databases could still be in place, update, and so on. Separate from the database, which is tracking the states of these assets, you have like a traditional recovery log, but souped up, which is tracking the list of transactions that have been executed. And the content of such a ledger would in some ways look like traditional recovery log, but in other ways look different. And also the manner in which traditionally Mohan and the likes of Mohan have dealt with recovery logs, they didn't worry about somebody intentionally going and screwing up the log by changing the stuff in it. Traditional recovery logs were also append only, but we didn't worry about misbehavior with respect to that thing being tampered with. Whereas in this multi-party kind of context, even that sort of thing is being done in a way where if people tamper with it, it can be detected and so on. So some of the ideas like the blockchain as a data structure is what is valuable from the original Bitcoin way of doing things that still is worthy of adoption, adaptation, and that's exactly what the permission networks have done. By the way, I'm going to be mixing up blockchain and distributed ledger and all that. For the purpose of this presentation, all those nuances are not so important, okay? But in any case, so the blockchain is a shared replicated permission ledger. And in order to do all this in a certain careful manner, to do the bookkeeping and all that in a more rigorous way than what traditional business process systems and workflow systems have done, we employ some of the techniques of the original permission-less blockchains. So another way of saying all this is, if you look at the scenario depicted here, on the left side is this chaotic way in which traditional multi-party work has gone on, where each one uses its own database system and its own separately developed programs, or even if they're using packages, they're all using their own ways of leveraging such packages, whether it's SAP or DB2 or Oracle or whatever, right? Or even file systems for that matter. And even though everything might be done electronically, there's still lots of point-to-point communication, and things could still be after the fact changed because the other guys don't have visibility into your database or the complete state. Even when the shipping companies give you a tracking number, just because you are able to get at some information from the other guy's database, don't think that you have complete access to their database. So if you look at the right-hand side way of doing the same thing, now it's much more clearly spelled out as to who the participants are, what the rules of engagement are, what the definitions of these blockchain transactions are. And in doing all this, the method to the madness is that essentially, in the simplest version, all the guys have the same database state that is being, in a coordinated fashion, modified. Okay? And this is the reason you can make certain assertions in the right-hand side way of doing things that you cannot make with the left-hand side. So efficiency is improved. You can track things in a more rigorous fashion, and also, the usual words you will hear about in this context, authenticity and so on, root cause analysis and all this kind of stuff is far better handled, or far more efficiently done, effectively done, in a less error-prone way and things like that. By the way, if you feel like it, you can question me even as I go on. So in terms of where we are, the way I summarize the state of the blockchain world is that it's as if like we are 35 years ago, a few relational products had come out, but you as the user of the relational products 35 years ago had to fend for yourself with respect to many aspects of how to use those systems effectively, under what condition one feature of a system is better to use than another feature, for what kind of workload. Oracle is better than DB2, whereas something else is better for this other kind of workload and so on. Also, they were hard to use. What kind of indexes to define, when to use lots of indexes and when not to use lots of indexes, OLTP versus OLAP kind of distinctions. So in the interim, between 35 years ago and now, as you all know, relational database systems have evolved in various ways. Functionality improvements, triggers and stored procedures and such things, as well as all sorts of database design tools and such were developed. So in a similar sense, with respect to blockchain systems, there are many systems around, but luckily it's not as bad as the NoSQL arena where there are way too many systems, because a lot of the work in the blockchain world has been done more in a consortium fashion, like the Hyperledger Consortium, the Enterprise Ethereum Alliance, and so on, R3, and such. Because of that, there are less number of these systems, but unfortunately, at least in the relational world, to begin with, all of them try to more or less follow the common conceptual model of relational databases that my colleague at IBM in Almaden came out with called, but the APIs were different. To begin with, Ingress at Berkeley had well as the language, whereas my colleagues in Almaden developed SQL. But in the context of the permission blockchains, not only are the APIs different, but even the underlying conceptual models, they are not the same. So there is, scope for improvements in that space also with respect to developing standards and so on. But compared to relational databases, in the case of blockchain, because of various factors, including open source, this, that, and the changed world and so on, between the time something was prototyped to when it got deployed, not just as prototype kinds of usage, but actually as production level deployment, the time period has been much shorter. Okay, meanwhile, of course, as you probably know from Mohammed's work and so on, there are any number of people in various places that have also said, hey, do I really need something separate from a database system that incorporates some of the functionality that I've been talking about, and that being called the blockchain system? Couldn't I suck into the DBMS itself some of this newfangled technology and enhance the traditional relational databases themselves to acquire blockchain-like features? And so that's also going on. And also there are lots of traditional database topics that are being rehashed and again being in some cases made to appear like there's some brand new ideas, including sharding and things like that being incorporated into blockchain systems, as well as things like working across multiple blockchains, heterogeneous database integration kinds of ideas, or two-phase commit kind of things that have happened in traditional database systems. And also, since a lot of the US and Western country people don't pay enough attention to China, I want to emphasize that the Chinese guys are extremely active in the blockchain space. And then Europe, of course, has a whole bunch of entities that are putting out reports and so on. So I'll let you go explore these things. The European Union Blockchain Observatory and Forum, they produce lots of interesting reports. There are also attempts to have a partnership across the European Union and some other countries, and even develop this European blockchain services infrastructure that will be a EU-wide, blockchain backbone that can then be used to implement government-related use cases as well as private enterprise and things like that. And then there's a similar thing called the International Association of Trusted Blockchain Applications. So in terms of what I said before, from February 2017, just about 3.5 years ago, production deployments have been going on. And every few months, you'll see something new happening. So even before Hyperledger Fabric reached the 1.0 status, which is more like production ready kind of status, it had already been in February 2017 used for a production deployment. That was the 0.6 release of the Fabric. But since that time, this concept of blockchain as a service offering has come out, which is a variation on infrastructure as a service and so on. So IBM offered in its blockchain platform, which was originally based on leveraging some of the really fancy features of the mainframe for both performance reasons and fantastic security reasons, which is a super duper version compared to what Intel has, which is called SGX, the secure execution enclave and so on. So since then, of course, lots of other companies have gotten into this game. And almost every one of the big players now has a blockchain as a service offering. The one saving grace in all this, plethora of systems that are around is that Hyperledger Fabric has become extremely popular, and almost everybody that offers a BaaS offering definitely supports Fabric. They might also support something else, but no other system is as popular as that. Meanwhile, of course, as I said, some companies have introduced, if not in a multi-node kind of environment, at least in a single node environment, database systems with blockchain-like features. That's, for instance, is the case with Amazon with its QLDB, and also more recently, Oracle has announced something called the blockchain table extension. In IBM, something was prototyped, but it was never commercialized. And also, the Chinese president himself declared that there should be a national focus on blockchain innovation about a year ago. So, and also there's also, there's all sorts of work going on in trying to make smart contracts be portable, and also even allow a single transaction to touch multiple blockchain instances. So-called blockchain integration. So there are multiple projects under the Hyperledger Consortium that are addressing some of these sorts of topics. So this is the point I made, that Hyperledger Fabric is very popular. And there are also many research projects. So it's not just commercial kinds of entities that are dealing with Hyperledger Fabric. Even at the University of Waterloo, there was fast fabric work that was done. So I've more recently found out, many universities across the globe are actually doing quite a bit of work with Hyperledger Fabric. With respect to standardization, I would say it's all still in very preliminary state, Mickey Mouse style progress. And there is this document that you can go look at offline. They are focusing on things like identity, interoperability, governance, and smart contracts and things like that. With respect to the whole myths that I've been annoyed about, there are many of them. All these tall claims about permissionless will provide high level of trust in a completely trustless environment and all that. A lot of these things are bogus, in my opinion, because even if you look at Bitcoin itself, what did it do? In my opinion, zero. Just sending money, Mohan sending Mohammed 10 Bitcoins and worrying only about that and nothing else is, in my opinion, who cares? Because I'm sending money to Mohammed presumably because he did something for me, goods or services. They don't model that aspect. So what if I send the money, but what he sent me doesn't work as he claimed it will work? What am I going to do? How do I make sure that I don't get ripped off in this scenario? So I can go on and on about all this. There are many situations where real world information needs to enter the system. How can some guy sitting in China, the so-called miner, validate a transaction where I'm saying the current temperature in Saratoga is such and such, and I'm entering that information? To a large extent in this world, you cannot get away from having identities and having some information about people, being able to sue people, having some organizations that you can appeal to, police, courts, whatever kinds of entities. So this whole notion of, it's a completely peer-to-peer network with no central authorities. I don't like governments. I don't like having to answer anybody. I don't think it's all very practical at all. And also this whole notion of, if you put some information in the blockchain, it's going to be there forever. Whereas if I put it into a regular database, I can yank it out. That's all false thinking on chain versus off chain. Because even in the blockchain, remember, what you put there is there forever and all that. But what about traditional databases? The log content is there. Even if you delete an object from the database, it's not like it's being vacuum cleaned out of the log. The log is no different from the blockchain data structure. This whole notion of creating money out of thin air, that's not based on GDP and goods and services and so on, is also something, and arbitrarily just speculating on this value with no real world implications is also something that to me is all bogus. It's all like pyramid schemes and such. And so I can go on and spend the whole hour or 2 hours discussing this, but I won't do that. And also all this
Mohan, just a quick question.
Yeah.
Mohan, just a quick question. So, I mean, I agree, but I mean, I'm kind of on the permission side, so I agree with most of the criticism. But the one thing that I've been recently started to think about is one key difference between the permission and non-permission is that the actual asset, that crypto itself, is part of the ledger. And look at traditional banking. I mean, we had this conversation earlier today too, is that they had the ledger, but the vault or the safe was outside the ledger. I mean, in this model, the safe is part of the ledger itself. And sure, the money that is being generated might be questionable, but that itself, that the asset to be physically part of the ledger along with the smart contract, well, it's not unique to permissions, but that part seems to be interesting.
Yeah, but I mean, you still need that thing to be recoverable and all that kind of stuff, right? I mean, I still would like in certain scenarios to have something in my hand that's a physical thing. I mean, see, I'm not saying digital currency is bad. In fact, China, that's what they're doing. I'm fine with what has been called, what is it called? I'm forgetting the name now. The digital versions of fiat currency, there's a term for that. That is okay. What I'm questioning is something that's not backed by fiat currency. The fact that it's part of the blockchain itself, I don't know why that by itself is a big deal. Because all this currency that's being created, if there is nobody guaranteeing anything behind it, like the US government guaranteeing the traditional currencies are like IOU. There's something like the central bank or whatever that's backing it, right? Even if gold backing is not there as it used to exist, there is still some real world entity, which is a reliable entity that honors it. There is no such thing as just because somebody created these bits in the computer, in the case of, let's say, Bitcoin, that any real world person necessarily needs to honor that thing, right? And people are creating their own currencies like crazy. And by the way, this is not like something brand new also. In the good old days, India's Mickey Mouse kingdoms and principalities and other countries, such things, had their own currency. But the world has evolved to a certain state. And in the case of Europe, even countries got together and created the euro. It's not like they were fools to do all this, right? That's why if you look at what Paul Krugman said, this whole notion of cryptocurrency has set the world back by 300 years. And Sambarda, Nobel laureate, who was an economist, also has said similar things more recently. So in that sense, we have to worry about reliability in many contexts, right? It's not just money. There are various other, my degree, certificate, all sorts of stuff we are all, with all the fires around, we need to definitely, of course, worry about keeping things in a safe fashion. But that doesn't have to be necessarily something like this blockchain. Blockchain is not like a panacea for all problems that you might have in the world, right? There are certain situations where some of its properties are so important that you are willing to compromise on some other properties. There's later a slide which goes into some of this kind of flow chart which you use to decide even between traditional transaction processing way of doing business versus blockchain way of doing for a particular use case that you're trying to implement. I don't know whether any of this addressed your point or not.
Well, yeah, it was just an open question. So I don't think there's any precise answer to it. I think just looking at traditional bank, I see they had a safe and they had a ledger. And go back 2,000 years ago, somebody wrote down the transaction and they put a little house or a safe that they could put the actual money in there.
No, but that's the reason, Mohammed, I brought up the point about that's not even true. This notion of, like, for instance, the gold, real physical gold having to back fiat currency, that used to be the case. You are maybe too young to even know there was such a thing. They gave up that in the 70s, I think.
Yeah.
And so the point is, even today with fiat currency, it's not like for all the currency that exists, there is definitely a physical form of it, even in the form of coins and notes. There's a lot of money that's part of the economy that's more like bits in the computer. And hence my point about, I'm perfectly fine with digital representations of fiat currencies, but I'm not convinced at all that you need to cook up these alternatives. Of course, then people have argued with me, hey, what about airline points and this and that? They have a very narrow role, but they're not like the way in which the cryptocurrencies have been talked about. Because people do bring up all these other money-like thing, points in various loyalty programs and so on. So there is a lot of money today. I mean, even when we do funds transfer and all that, you think we are really sending physical money? No, obviously, right?
Yeah.
Those are all just transactions that involve, in a more organized fashion, essentially who owns how much money is being kept track of. So it's not like traditional fintech didn't think about, if you like, storing money in computers and dealing with it at that level, and not every time dealing with it with physical currency and so on. That would be my way of addressing your point.
Yeah, makes sense.
Anyway, there are lots of problems that have been there with permissionless networks. And I didn't even show this other one, which involved one guy who had an exchange dying, and even his wife didn't know what the password was. People who kept their money there sadly lost all that money, just like that. And you have no place to go whine about this, right? So in that sense also, by the way, this whole business of, permission less is completely distributed, whereas permission decentralized is bogus claim. In fact, it turns out a lot of the individuals who have cryptocurrency, they were worried about losing their money because they forgot their private key or whatever. So guess what? They stored them in exchanges. This is nothing but a pseudonym for banks. So much for these guys claiming that they're eliminating middlemen, blah, blah, blah. So in many such ways, a lot of the claims that have been traditionally made by the permissionless people in some kind of anti-government, and I'm going to be a libertarian and so on, have actually all, in the practical sense, become bogus. In fact, somebody had even claimed, oh, you think everything that happens in Ethereum is all done in a completely distributed? Actually, what's his name? Buterin decides lots of things. It's highly centralized. You know, how the system evolves and all this kind of stuff, right? Forking and this and that. So people would like to believe that it's actually, ordinary people determining everything in a collaborative way and all that. But as a matter of fact, even the bug that was found in Zcash, which they claimed they kept hush-hush even within the company for 9 months before they found a fix for it, which could have resulted in all sorts of fake things having been accomplished, even history being rewritten and that sort of thing. guess what? In spite of the fact that it's open source and supposedly, just because it's open source, it'll be bug-free or error-free and all that is nonsense. So these systems are so complex. Just because it's a public thing, that doesn't necessarily guarantee that they don't have bugs, that people still cannot do some hanky-panky and such. So in so many such practical ways, there is too much of hyped up claims that have been made about why permissioned is so much, permissionless is so much better than permissioned. Anyway, getting back to technical things, the point I make is that both in the distributed systems area and database systems area, there are many topics which all have a bearing on what goes on in this blockchain arena. And in that sense, it's not like the blockchain way of doing business is completely, brand new technology in every which way and so on. It's actually, how you, squint your eye to see things in a certain way that will let you know that I myself worked on many of these things, by the way. Even Byzantine Agreement Protocol was something I worked on back in '82, my first year at IBM, along with the work I did on presumed abort and presumed commit, two-phase commit protocols. In POTC 83, I had one paper on the hardcore thing, which is the presumed abort, presumed commit. The other paper was how to combine that with Byzantine Agreement Protocol in order to worry about Byzantine failures. So
just
it's
a
not
side
like,
note, this two-phase commit, that was our first paper to be covered in the graduate course. So it's always been one of the first ones to be covered.
Wonderful. So, but I also have worked on workflow management, business process management. So when I make some of these comments, it's not like I'm just BSing my way through these things. I have personally worked on many of these topics. And so as a result, I know how traditional workflow systems worked, what their shortcomings were, and why in many ways this more organized way of doing things, and the blockchain way of doing business has brought to that kind of scenario that is a positive step. But at the same time, it still involves certain song and dance with respect to how a transaction gets executed in the blockchain way of doing, even in the permission environment, which makes it more expensive than traditional, distributed databases with replication and primary copy approach and all this kind of stuff. And so I have some slides later about that. But in any case, what I wanted to say is that this slide, this picture, which comes from Beng-Chin Hui and his colleagues' paper in Sigma 2017, in a sort of big picture sense, says what the three most important aspects of blockchain system are. Consensus layer, which determines, in what way transactions get picked up for execution and how they then get incorporated into blocks and how the blocks get added to pre-existing blocks in the blockchain. Then the other one is the smart contract execution engine. There are various aspects to this, what language you're allowed to code in, what constructs are permissible, because certain systems require that the smart contracts be deterministic. So you cannot do things like look at current time or look where the moon is and so on, because the same contract on behalf of the same transaction might be executed in multiple nodes. And if you have any such non-deterministic things, then these different nodes will get different results. And as a result, if the order of execution of the transactions has been predetermined, and then they are all let loose to go execute these transactions, they'll wind up with states that are not mutually consistent. And also the way in which the persistent state is kept track of, which is the data model layer. What kind of database system are you allowed to use? NoSQL, relational, how reliable it is it versioned or not, and so on and so on. So there's lots of things that one can spend time on in discussing something like this. To make matters even more exciting, there are many other aspects of the architecture of these systems, features, where there are many different ways in which something could be accomplished, and different systems have chosen to go do those things in different ways. The bottom line is By the way, for each of these bullets here, I can spend, 20 minutes, 30 minutes, whatever, discussing the pros and cons of doing it one way versus another and so on. The bottom line is a lot of the work that has happened, especially before quote unquote research type people got involved, where it was done primarily by product kind of people or other, people who think they know a lot, but they don't have enough experience. That's one of the problems with this open source business, right? Uh, Sorry, lots of you are young people, but there are a lot of 20 somethings who do a little bit of reading and then they think that, why waste time reading Mohan's Aries paper or this or that? And then they think this is how MongoDB and all these NoSQL systems came about, right? They just do some seat of the pants design and they don't describe in enough detail what they did for other people to stare at them and see whether they've missed something. The kind of thing that Mohammed actually said, that the pain he went through trying to, rationalize the design he came up with for one aspect of a system, how it interacts with other aspects and all that. Design reviews, code reviews, architecture reviews, and so on. And so the point is, lots of things have happened. While it's good that in a short amount of time, many systems got developed, at the same time, it's also bad because in the desire to do things fast, people have not been as rigorous in going through enough of the what it takes to make things work in a reliable way, in a long-term way, rather than just, oh, my Silicon Valley guy wants to do a itsy bitsy prototype and find some people, con some people, if you like, into giving him money to either do a few more things and then go IPO or find some suckers in some big companies to buy this, prototype which does a few things, not necessarily even dealing with all the fringe cases, but it does the average case. And then let those guys worry about doing the real thing later on. These guys who did the initial thing laughed their way to the bank, and then IBM or whichever company acquired this not yet ready for prime time thingy. Then the jokers and those acquiring companies have to deal with really making it industrial strength and so on. Or in the case of startups, the first set of people go away after the handcuffs come off them and they're able to cash in. And then the new set of people who get hired, they now have to make sense of this not necessarily well documented code as well as design documents that might have talked about the design in a more or less, this is how it works, not necessarily rationalizing why that's correct or whatever, but at least describing what it does, but which wasn't kept up to date as the design evolved or bugs came to be noticed and such. So it's in that sense that my point is there needs to be more rigorous way of looking at these existing systems, how they do what they do and whether they are correct, and do comparisons and all this. So a preliminary piece of work was done by the people in NUS, Beng Chin and others, as a follow-up to that Sigmod paper that I referred to before. But these are not people who themselves had developed the Hyperledger Fabric or, Ethereum or this or that. And so they couldn't always be able to guess what the original people who did some of those things had in their mind when they did something. This is like, now the Supreme Court people trying to interpret what did the people who framed the Constitution of America 200 plus years ago thought when they did something, when they put in something in the Constitution. All those sorts of things you have to go through. I already talked about this blockchain versus recovery log. There are some similarities, but there are also differences. And so, but to that extent, you need to think about this because there are any number of people who go say, oh, don't put something in the blockchain because you cannot take it away, but stick it into the regular database and then put only the hash into the blockchain. And they think that, oh, because I can delete the object in the database, that now makes it disappear and I don't have to worry about GDPR and all this kind of stuff, then that's bogus unless you vacuum clean the database recovery log in the database context. the two are the same. And there are people now who are actually worrying about, even in the blockchain context, what might be considered anathema, which is even forgetting stuff in the blockchain data structure, because you need to actually worry about things like what happens if, after all, these smart contracts are nothing but like traditional application programs. What if you had a bug in your smart contract which clobbered the state of the assets? What are you going to do? Traditional database systems had to worry about these sorts of things, right? Your new version of your app had a bug in it. And so you can't do compensating transactions and all that because you don't even know exactly what the effect of that bug was. So normally, before we install a new release of a piece of software, you take a backup of the existing state of the database. And later on, if things crap out, you essentially do what's called a point-in-time recovery. You restore the database to that earlier state. Yeah, that means that it's as if you have amnesia with respect to all the transactions that got executed since the time you took that backup. And as people have asked for that kind of functionality, even in the blockchain context, or at least for the IBM blockchain as a service offering. So when it comes to going beyond all the, what idealistic minds might think of, and you have to really have systems that work in practice, you do have to think about these sorts of things. And you can't be so puritanical that, oh yeah, this history can never be touched and so on. You do have to think about a suffix of the blockchain having to be lobbed off because of these kinds of bug situations and things like that. In some ways, you've already seen these things, even in the quote unquote puritanical sense, all this forking and all that, when they change the block size and things like that, that have happened in the context of Ethereum, for instance. Replication, I already mentioned that traditional distributed database systems have had replication ideas. It took a long time for some of these things to get implemented in relational databases, but even Lotus Notes from late 80s, even a what I consider to be the world's first semi-structured DBMS, long before MongoDB, all this, had this notion of disconnected operation and being able to do updates while you are disconnected. And later on, when you reconnect to the server, you might discover that in parallel, two different people had done conflicting updates and so on. So in that kind of a scenario, we have had various approaches, right, as to how, if you have replicated databases, things get done. Meaning, in one approach, you do the update, the whole transaction gets done in the primary copy of the database, and then you use the log records produced in that one place in order to bring other copies up to date. But this required that these two systems be exactly the same with respect to database system and page sizes and this and that, because the recovery log, if you want to use it in that fashion, needed all that, LSN and all this kind of stuff. The next approach was you want heterogeneity. The primary system might be Oracle, the copy system is DB2. And so in this kind of scenario, you execute the transaction on the primary, which produces log records, but then the log records themselves are made use of in order to create higher level statements, which then get sent to the other guy in order for him to now, from a high level perspective, redo those transactions. In this fashion, you can do subset replication, the systems can be different, page sizes can be different, and so on. This is what the IBM Q replication product allowed you to do. But this required some, interesting things to be done, because in the original system, things happened in parallel. If you do this in a naive way, then in order to guarantee that it's all going to result in the same state on the backup, you might choose to do things serially. Every transaction that got done in the primary gets redone in the serialization order on the backup. But that would mean that then the backup might not be able to keep up with the primary, because the primary is cranking away by executing transactions in parallel and so on. So you had to then come up with all sorts of interesting ways of analyzing the dependencies between transactions and then doing them in a parallel way and things like that, while still preserving, where it's required, serialization of transactions executions, but where you can do it, execute multiple transactions in parallel on the replica. And then, of course, Stonebreaker goes around saying Mohan is crazy. We don't need any of this nonsense. I'll just capture the SQL statement on the primary and just re-execute it on the backup. Guess what? It doesn't work. He doesn't tell you the full story. The problem is that if that SQL statement had any kind of non-deterministic constructs, as I talked about before, looking at the current time, what the weather temperature now is, and so on, you cannot just take the original statement, because then when you re-execute it on the backup, the results may be different. And so non-determinism creates conflicts, as well as he also does everything in a serial fashion and so on. So I can spend a lot of time discussing all this. But the important point is, in the case of blockchain, a lot of these sorts of situations are handled by, in some random fashion, in my opinion, an optimized fashion. The transaction order is determined upfront, and then all the copies effectively execute them in that same order. Whereas in these other ways of doing it, it's all sorts of things like the locking order, this, that, and priority and all that on the primary that determines in what fashion transactions get interleaved. And they don't take into account, as I said at the very beginning, greedy things like who is offering me how much money, and I'll use that as a way of figuring out which transactions to pick and which transactions might, as a result, get starved and things like that. Yeah, we do have some priority and all that, but at the same time, we'll also have some service level agreements and all that in order to bound the amount of time it might take before a transaction gets executed. So there's lots of such comparisons that can be made. One of the major architectural differences between the more or less permissionless way of doing business versus the way in which, starting from version 1, Hyperledger Fabric chose to do the handling of execution of blockchain transactions is what's talked about in this picture. In the case of all these other guys, they first, through the consensus protocol and all that, determine the order of transactions that they choose to pick up for execution. And then in parallel, the different nodes execute them. And this is why that deterministic aspect of the smart contract becomes important. And then they update the persistent state. So there is no communication in that middle step between the different participants to make sure that they are all in agreement. Whereas in the Hyperledger Fabric way of doing it, starting only from version 1, prior to version 1, it also followed that upper model. They do this initial simulation of transaction execution, which results in read and write sets being determined. No actual updates are performed. This is like optimistic concurrency control, during which time it's okay if there is non-determinism, and as a result, the results produced are different, because at the end of that simulation, there is still an opportunity for the client which initiated the transaction to even make use of these different results and decide to take an average, take max, or insist on them being equal, okay? In any case, based on this initial simulation, if things look good, whatever that means, in a particular context, in a particular use case, for a particular transaction, meaning blockchain transaction, if things look good, then they go through this business of either, in the case of initial release of Fabric, a single node which acts as the orderer of the transactions, or if you're a little worried about certain aspects, in a consensus protocol way, determining the order in which these transactions which have gone past the simulation phase get executed. But the important distinction is that once that order is determined, in the validation step, you are not actually executing any smart contracts. All you are doing is that, based on the read and write sets that were produced in the first step, step, the simulation step, you are making sure, is the world with respect to, and this is like the validation phase in optimistic concurrency control, is the world still the same with respect to what was read, which was then used to determine what needed to be changed? If what was read during simulation is still in the same state at the validation step, then they declare such transactions can succeed now, and then they take the update and dump it. So the crucial point is smart contracts don't play a role during validation. This is again the original way in which in version 1 Hyperledger Fabric things were done. Since then they've been doing that, but there may be some twists that have come in the more recent past. And if the transactions validation succeeds, just like in optimistic concurrency control, then they go and incorporate the changes that had already been decided during the simulation phase into the persistent state, okay? And all this is described in this 22 author paper for which I have the URL here, which was published a couple of years ago.
Just a quick question, Mohan.
Yeah, go ahead.
So in terms of the simulation, I mean, if the transaction is still non-deterministic, the simulation will not get endorsement. So it still can't handle the non-determinism.
No, all I'm saying is that that's where I gave you a mundane example, like if one guy says, something and the other guy says something else, based on what this particular transaction is, what the use case is, the client might choose to even combine those two pieces of information, come up with an average and say, I'm going to now say the right set should be that. See, the architecture has all that flexibility. Whether the Hyperledger Fabric, a lot of the implementations chose to do that or not is different. But if you look at the, I forget now what it's called, it's the, it's called the,
you can basically have a policy to somehow.
I'm trying to recall what the name of that policy is. The endorsement policy, the validation policy, and so on. Yeah. Those are the ones that determine what needs to be satisfied. You can even say things like, I asked for endorsement from 5 people, and Mohammed is such an important guy, unless he blesses a given transaction and 2 others bless that transaction, it cannot be committed. But Mohammed always has to endorse. Amongst the remaining 4, it's enough if 2 of them endorse. So the Hyperledger Fabric functionality allows you to specify such things.
And can it be actually used in practice? So that makes sense. But do you think it's practical to be able to come up with all these different kind of policy?
Yeah. I believe it is. This is no different from, you might check with a bunch of establishments whether somebody is trustworthy or not, right? And you say things like, this is no different from in that sense, the score that they give you, right? Creditworthiness score. And what do? They go to multiple places, they grab some information. All of them might not say this person is the world's most trustworthy person, but they are looking for a certain level of feel-goodness, right? It's things like that is what I'm saying.
I have a question. So,
Sure.
So Hyperledger's claim that it's execute order architecture.
Right.
Is it actually an execute order architecture? Because assume we say an endorsement set consists of 4 people, and there are many clients who are sending their smart contracts. And now, if we just
be careful with terminology. Many clients are sending transactions.
No, they're smart contracts to same set of endorsers.
No,
it is
no. Okay, just from a terminology perspective, let's look at this picture. Smart contracts exist in the endorser nodes only, right?
Yeah.
The clients are only submitting transactions. I just want you to be clear about the mental picture.
Sure. So clients are submitting their transactions,
right.
And now these endorsers basically have to find the read and write sets, right?
By simulating.
but they have to do it in some order, right? I mean,
No. Absolutely not. Like this picture is showing. I assume you're looking at the slide. The transaction is submitted in parallel to, again, there are various options. How many endorsers you choose to use and all that, that's not part of the architecture of the system. That's all use case defined things, okay? So there could be 10 endorsers. This client, for whatever reason, says, I'm going to choose these 5 endorsers of the 10 and submit the transaction to them. Not all the endorsers are necessarily involved.
But I'm saying now, if this client wants to choose, so there are 2 clients, A and B, both end up choosing the exact same set of endorsers.
Yeah.
It is possible, right?
Yeah,
so
yeah,
now they both set, and they both have this complex transaction. It's not just simple transaction where you can just find read and write sets. It's a complex transaction.
Okay.
Now, for a complex transaction, you might have to actually sort of start executing it before you can actually find the read and write sets. Not every read and write set is discovered at the beginning.
No. Okay, so before you go further, I want you to look at this picture. So essentially, when this is showing what's happening in, let's say, one endorser node. When the smart contract executes, it makes, I hate this, IBMers did this, but shame on them. They chose a dumb key value model, get, put, delete. Those are the only things that you could do at the beginning, okay? Because they used a dumb NoSQL key value store. So the get calls get sent to the database system, which has the current state, right? And the put calls and the delete calls are trapped by the layer above the database system. Only the get calls get the latest stuff that happens to be in the database at that point. And any puts are stashed away, which means in particular, you don't get to see your own updates during simulation, okay? So the point is, no change is being done to the ledger database while this smart contract is executing. This is all really bad stuff because essentially the layer on top gets a share lock on the underlying database as a whole while it's doing simulation. That's sufficient because the actual updates are not being sent. Whereas later on, you'll see when the blocks are being processed during validation and then commitment, an exclusive lock on the whole database was acquired. So even if 2 simulations go on in parallel, they all still see the same state.
Okay. Yeah.
And in particular, what that means, you might be onto something that you're not verbalizing. Take the simplest case where every bloody transaction wants to just increment a counter by 1, the exact same counter. 100 transactions could get submitted in parallel. They'll all do their simulation, and then they all send their read set and write set to the orderer, and he puts them, let's say in some random order in a new block and sends them. Guess what? How many transactions will succeed, if at all any succeeds?
Only one of them in such a case.
At most, even that might not succeed. The very first one also might not succeed because between the time the simulation happened and all these 100 guys got sent to the orderer, yet another block could have arrived that was in transit or being formed even as these jokers were being simulated. And that could have already changed that value. So believe me, when I heard all this at the beginning, I'm like, what is wrong with these people? Who are these people? Non-database people doing all this BS. And it's crazy, the degree of concurrency and all this kind of stuff. And all because they also use this dumb system which didn't have multi-action transactions. They couldn't rely on any locking and all that of this, level DB and all this kind of stuff because they were not full-blown ACID transaction systems, database systems. And so there's lots of this kind of serialization which in spite of permissioned being better than permissionless, causes incredible amount of inefficiency and transactions getting blown away and so on. So do you still have a question or?
No, it makes sense.
Okay.
So I have a question here, sorry.
Sure.
You are saying in Hyperledger Fabric, they are getting endorsed, and after that they get ordered, and after that they will get validated. You mean if there are hundreds of just incrementing the same value in the same block, one of them at most can succeed.
Exactly.
And the rest of them will get invalidated during the validation phase.
Right. So the assertion is, if you look at this picture, after the ordering service does its ordering, it sends this newly created block to everybody, endorsing peers as well as this so-called committing peer. The difference being, by the way, all this was introduced in version 1. Before version 1, they didn't have these distinctions. The committing peer doesn't even have the smart contract installed in it. All it's doing is that it's tracking changes to the database state. You might wonder, what use is it? Presumably, you can run analytics over there. And there are other things I can think of. But for the time being, let me stop at that. But the endorsing peers, which might have been involved in the simulation, like what I'm showing here, they have amnesia. Once they've done their simulation and sent back the result, read and write sets to the client, they don't have any information about the fact that they did that simulation and so on. So when the ordering service sends a new block of transactions, they start from scratch in the sense that they don't have any prior knowledge. They might have seen those transactions or not seen, doesn't matter. All they do is one by one, and that's another bad thing, right? They start from the beginning of the block, one at a time, they process the transaction. I'm like, this is nonsense. Remember, I talked about that replication where I said, if the replica does serial execution, it won't be able to keep up with the primary if its primary was doing things in parallel. Having done all that kind of work, this was all like mind-bogglingly naive for me. But in any case, that's what they chose to do. I was not in the picture when they were doing all this. But,
yes. But my question is still there. My question is that you are saying that transactions can get invalidated because another block can come during the validation of this block. But isn't it that every block gets in a completely serial order in the orderers? So the only transaction that can get validated because of the other transaction, they should be in the same block. Invalidation cannot happen because of the previous or the next.
No. Okay, then you didn't understand my example.
I'm saying these blocks are getting ordered by the ordering services.
Yeah. Okay, hold off on it. Let me
let me say one more thing and then you explain.
Okay.
Once block gets ordered and gets validated, some of its transaction can get validated. All the endorsers will update their snapshots.
Right.
And they endorse on their new snapshot.
Okay, so that's where there is a slight problem. Let me just explain what I'm saying.
Yes.
When simulation is going on in, let's say, one endorsing peer, the state that you are seeing might be as of the 8th block having been processed. This doesn't mean at that very moment, the ordering service is not already finishing up producing block 9. I said 8, right?
Mm-hmm.
Yeah. This new block 9 has been produced, and the endorsing peer hears about 9 after it had finished simulating the transaction of interest or the 100 transactions of interest. And so by the time these 100 guys go to the ordering service and get into block 10, and then that block 10 is received by all the nodes, and they go through validation. The current state of those nodes will be as of the end of block 9, which is different from the state as of the end of block 8, in which the simulation got done for those block 10's 100 guys.
Yes, I see.
This could be a case. I'm not saying it's always the case, right?
I think I understood your point, but another question: can't they optimize all these inefficiencies when they are making the batches? Can we do the prediction on?
Okay, so this was one of the things that I felt like throwing up. I'm like, first of all, even as you do the ordering of the transactions, could you please try to do these things in an order that more things could succeed? So for instance, eons ago, when we did deadlock detection and all that, if there is a deadlock and you have a bunch of transactions and one guy needs to be kicked out, we don't just randomly pick a guy, right? We try to minimize the amount of useless work that gets done by picking the transaction which has done the minimal amount of updates and things like that, because you are going to roll back a transaction, right? There are many things like that that could be done if only the ordering service would pay attention to the read-write set and things like that, and determine dependency between the transactions that it has got in its hands, and it's now trying to put them in order. Mind you, this is not even greed-related stuff I'm talking about, right? You, of course, have in the permissionless one also some other nonsense coming into the picture. Here I'm saying from a pure performance perspective, you could even, in fact, in the particular scenarios I told you, you could even potentially kick out transactions and give the, hey, guess what, you are a loser, right, from the ordering service, instead of wasting the time doing the sending of these transactions to the nodes and let them going through all the validation and so on. Because he could even see by just looking at the read and write sets in the list of transactions he has got in his hand, that guess what, a lot of these guys are going to be losers. But they don't do all that. In fact, they say, wow, it's a great thing that the ordering service doesn't pay attention to any of this read and write and so on. And to some extent, I can understand that too, because there are some scenarios where they want to keep all that hidden from the ordering service because it could communicate some, secrets and so on, right? But at this point, and in fact, by the way, there are other people who have subsequently come up with all these, in my opinion, very obvious kinds of things that should have been done from the beginning. So even Fast Fabric does a number of things to improve performance, not all of which is like some super duper highly innovative stuff. In fact, for that reason, I don't know if Mohammed was there when, what's his name? The professor from Waterloo that was at our...
Lukash?
Who?
Lukash?
Oh, no. The
Tamer?
No, the one from Waterloo who worked on Fast Fabric, who has moved to Cambridge now. Anyway.
Oh, I know what you're talking about, yeah. I forgot his name.
It's there in my throat, but it's not coming out. He said that he had trouble getting his paper published because a lot of people said this is all just engineering. And he himself was saying it. So even though they are valuable in terms of performance improvement, it's not like, some revolutionary new algorithm and all that. So for instance, he would send to the ordering service only the IDs of the transaction and not the payloads, all this read-write set we are talking about, and then get back the order and then put in the payload. Apparently, in the past, with all this use of Kafka and all that, a lot of stuff got shifted around with no use being made of that. So even some of the parallelization of processing the transactions during the validation and commit phase, more recently, people have worked on. But how much of that has gotten into the mainstream code base of Fabric is another discussion. But yeah, for a database person, there are way too many obvious inefficiencies that what I consider to be non-database people who initially did the work cooked up. And this goes back to my initial complaint about if people don't do enough homework, they start with extremely naive things, and then they try to gradually evolve the system and so on. But you might be so unlucky. The first version was so stinky, you never even get a chance to fix it because nobody bothers with you. So that's the danger of oh, let me quickly produce something. I can always fix it up later on, blah, 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 which is, keep it simple and stupid, all that KISS principles and such that many people tout as a good way of making quick progress, doesn't always result in, this is like Windows 3.1 that Microsoft shipped and the whole world was the testing people, instead of they themselves doing more testing before putting it out. So we've had all these discussions between IBM and other companies' way of doing this. So anyway, so can I go on or?
Yes, thank you.
Okay. Anybody else has any questions? There are more papers that you can go and look at that go into more of the nitty-gritty about all this. So let's now come to, if you think what you heard was bad enough, let me tell you what more is bad about all this. The simulation concept requires the layer between the smart contract and the database state and the state database having to analyze DBMS calls. What do I mean by that? Remember in this picture, I said this get calls get sent to the DBMS and then the result comes back, whereas the put and delete are kept in the layer above. Essentially what's going on is that here, in order to determine the read set and the write set, the guy on top is effectively interpreting these get and put and delete calls. It's okay in this dumb scenario, right? But the minute you start supporting SQL at this level, in order for people to be able to do much fancier modeling of the assets and so on, why should suddenly, just because you get into the blockchain world, you should drop down from the semantics and the power of SQL way of modeling what you have been doing in your organization with workflow, whatever, come down to this dumb level of get, put, delete, and all this kind of stuff. So if this becomes SQL, guess what? Essentially, this layer has to understand SQL semantics, not just the parser and so on, but even the semantics, not just the syntax. And so that's where life gets really messy. And that has to do with things like this, right? There isn't like a clean cut, oh, this is read statement, that's update statement. You have mix of read and write, which is like update where, and then you give a condition, or inserts with a subquery, insert into this table the result of the subquery. So now you would have to deal with having to split these things, meaning where I had get before, now I have to take that part of the SQL statement that is doing the read and shove only that into the DBMS. But anything that actually causes updates, I would have to keep it on top. But updates could be complicated, right? It could be add 10 to the existing value in this column. Are you going to declare as write set that statement, that summation, or is it the end result that you're going to be having? So quickly you can realize that lots of things will get really complicated, especially if the isolation level you want to support consistency, read consistency, and so on. You want serializable execution. The not found also has to be remembered. See, originally they only remembered what was actually retrieved from the database system, because the only call available was get. You couldn't do a range scan originally. So you could only say, I have an object ID, now give me back its value. You couldn't even find out what are all the objects that exist in the database. This is kind of crazy, right? But anyway, so why I'm saying all that is, once you generalize the notion of what you are retrieving and what you are changing possibly and so on, you might have to re-execute the query as opposed to just checking whether what you retrieved before is still in the same state, which is what Fabric does. Because it's possible that you originally said, tell me how many green cars are there. And it came back with 8. Now, if you re-execute at validation time, it might come back with 10, because in between, 2 new cars got added. And under that condition also, you have to blow away the transaction. So you would have to remember the original query, not just the end result that came to you as part of the read. So you would have to re-execute the query during validation phase. And so now, of course, then the question that comes up is, what if different people want to use different database systems as the state database? One guy wants to just be, dumb and happy with key value store. Another guy wants SQL. What do you do now? What language primitive are you going to have with respect to data manipulation that you're going to permit in that smart contract if it's for the same use case? The dumb thing to do would be to treat a relational system like a key value store, which means you don't get to benefit from the power of the SQL system. But if you permit SQL, but you are stuck with a key value store, then in the layer above the DBMS, you would have to compensate for all the missing functionality of the key values store. So in my project that I was doing, where I was trying to add relational database support to Fabric, I said, my goal is not to be able to port the smart contract, which has SQL in it, to non-SQL systems. I'll use standard SQL. As long as that SQL is supported, one guy could run Oracle, the other guy could run DB2 and so on as the state database. So this is the work I was referring to. So the name of the professor is Keshav. You see his name here as the last author. This was the fast fabric work done at University of Waterloo. So they did certain things. This is where I was saying the list of transactions that are received by the ordering guy. It picks out only the transaction ID, sends it to the Kafka, which does the ordering of the transactions. And then when the list comes back, it puts those transactions in that order in the new block, and then adds the payload and produces the block, and then sends it to the different people and so on. And they've also done this parallelization and things like that. This is what they call the new peer architecture. And they're also, keeping an in-memory version of the data in the, this is now like this peer acting like a database system, right? The store below, you understand what I'm saying? See, this layer, which has the database as its own buffer manager, where things are being cached. What that work is saying is that in this layer, they're going to cache certain things. So this is crazy. I mean, after a while, I said, this is nonsense. Why are we building a database system on top of a database system instead of pushing things like simulation into the DBMS, which is what my project was doing at Almaden, and let the determination of the read and write sets get pushed into the database system. Okay. Anyway, there are lots of use cases. I don't know whether I should spend my time too much. Hey, Mohammed, you tell me. I have stuff that talks about different kinds of use cases, and then I talk about the fact that not all use cases should be implemented using blockchain, or only implemented with traditional transaction processing, because each has its own pluses and minuses. So you have to look at various requirements that you have in your use case scenario. You'll find lots of people producing flowcharts like this. Unfortunately, this particular one has a bug, and it says, if you're dealing with physical assets, you can't use a blockchain, and that's bogus, okay?
So I suggest maybe another 10 minutes for like some of the more interesting material that you want to cover, and maybe like 5 minutes to kind of close the questions and vision and things like that.
Okay, so this is just talking about the fact that just because you're now going to do things in a blockchain way, this doesn't mean you throw away all your existing backend database systems and transactions and so on. You might still, accept orders, let's say using the blockchain way of doing business, and ship the produced goods using the blockchain way of doing interactions with your other people, with other organizations. But the actual production of the ordered goods might still involve communication between the blockchain network and your backend MRP manufacturing, resource planning systems, SAP, this, that. So there can be triggers that go from one side to the other side. An order has come in, hey, start making it. And then when the order is prepared, the material is produced, you send a signal to the blockchain system to say it's ready for shipment and so on. So there can be these sorts of interactions. When you have physical goods that are being dealt with, then you need a way of recording something about the physical item, diamond, whatever, a bottle of wine, in the blockchain. How do you now make sure that I send to Mohammed a real diamond and he is a sleazeball guy, he is now trying to tell somebody else, this is the same diamond Mohan gave me, and with a markup, he wants to get more money. So just like humans are authenticated with iris scan, this, that, IBM guys cooked up this whole notion of the crypto anchor, which is a way of uniquely identifying something of a physical nature. And that is done based on what the item is. Diamonds have some internal thing that's like an X-ray or fingerprint. In the case of cotton, you can look at the spectral value. In the case of olive oil, expensive one, you can look at the viscosity and so on. So this thing that you see in this picture is a fancy lens that can be attached to the mobile phone, which allows you to measure certain properties, physical properties, which then can get recorded. Obviously, you will do this, and this is why I'm saying you can't just say, I don't trust anybody. The guy who produces the real thing is the one that's going to record this. This is like Gucci putting some 3D logo, whatever kind of thing, right? You do have to have certain level of trust. Of course, over time, if they are flaky, then their reputation goes to dogs and nobody cares about them, right? They get booted over the network and so on.
So I don't know, Mohan, if I should thank you now or wait till the end. Any scam that you produced today, I was the bad guy, and you covered every single possible attack, and I was always the bad person in it. In the examples.
So. Hey, only one example I made you a bad person.
No. There was a lot more. Every possible scam, I think I did it today, but that's good.
No. So there are other situations like, things like tablets and so on, drugs, microfluidics, all sorts of good technologies used. I highly recommend this paper that's referred to, Crypto Anchors, in the IBM Journal of R&D. I don't know if you have it in your list, Mohammed. It will be a good one to at least briefly talk about in greater detail than I'm doing.
Which one?
This is the Crypto Anchors paper at the bottom left corner.
Okay. Yeah, I will add that.
You have access to the slides, so you can look at all this later.
Sure.
So in general, the point is, when it comes to physical goods and such, there are ways in which you can tag RFID, whatever, all those sorts of things, it turns out none of this is like 100% guarantee, but these are deterrents, right? So it turns out something can be done in a way where if you do an ordinary copy, the line will look like a continuous line. But if you look at it under this kind of fancy microscope, it'll be a discontinuous line. So if somebody wants to, fool you by photocopying the original thing, then it can be detected because of this kind of property. So there are things like that. This just then goes into discussions about, how you evolve from Bitcoin to Ethereum. One of the great things that the Ethereum guys did was introducing the notion of smart contract, go from just dealing with this one silly thing called Bitcoin and nothing else, to actually doing something of more value. But they still had all the bad properties of Bitcoin in terms of proof of work, and they introduced additional things like gas and so on, and they introduced their own currency. But in my opinion, the bigger thing that then happened was the enterprise Ethereum, which tried to make it a permissioned one. In this context, the JP Morgan guys developed Quorum as a particular way of introducing a permissioned variation of original Ethereum. But it turns out they didn't know what to do with it after they implemented some internal solutions. So more recently, Consensus Network has bought the rights to that software. But the original guy who did this quorum has made all these statements. He essentially says, Ethereum is not going anywhere, who cares, blah, blah, blah. I'll let you read all this at your leisure. But meanwhile, there is the Enterprise Ethereum Alliance, which has come out with client specifications and high-level architecture kind of way of trying to let many people implement, but the organization itself doesn't implement anything. They just come up with specs. So the Quorum network, I could spend time, I don't have the time now, as to how within a single network, and by the way, this happened with Fabric also. If you thought that you're looking at transactions that are done in the permissionless was bad, guess what? Even in the permission, even within a single network, people didn't always want every participant in that network to see every transaction. So in the case of Quorum, they have this notion of a public state and then private states. The public state is common across all the nodes. The private state, as you see in these colored blobs, only subsets of the node have the private state. But unlike in Fabric, here they have only a single blockchain and a single set of smart contracts and so on. So this is a problem because the details of what's in this private state are not described in the blockchain. Only for the public state, they describe all the details. In other words, if one of the private state databases blows up, you cannot reconstruct its states by merely going through the blockchain, which you can do in Fabric, for instance, or even here, if a public state gets clobbered in one database, in one node. So in the case of the private state, the only way to recover this lost thing is to go to some other node which has a copy of it and get it from there. In the case of Fabric, they never did that. The way they initialize a node, if you add a new node and its state has to be from nothing in it to the latest state that the other guys have to be accomplished, they start with the empty state, go back to the beginning of the blockchain and re-execute all the transactions, which is mind-bogglingly dumb also, right? This is not how you initialize a new copy in a distributed database system. Anyway, so there are lots of things I can talk about, but the equivalent thing in the case of Fabric that was done was within a network, you can define the notion of channel where only subsets of the members, are part of a channel. But the way Fabric did that, starting in version 1, each channel has its own state database, blockchain, and set of smart contracts. And so they don't have this particular problem that Quorum has, the way they chose to do this, subset of the people being aware of certain data and certain transactions, okay? I talk about, Hyperledger Besu, which is a brand new implementation of the original Ethereum client. And then I talk about the evolution of Fabric, what has happened in version 2. Unlike what I think Mohammed said at the beginning, unfortunately in Fabric, the smart contracts were not installed in the nodes in a transactional way, meaning the smart contracts were not part of the blockchain itself. I don't know if you knew this, Mohammed. I thought you said smart contracts were part of the blockchain. That's not how Fabric did it. I think somebody else makes it part of the, just like any other data, even the code is considered to be part of.
I meant like the Ethereum and like the Bitcoin.
Yeah. So Fabric is different in that sense. But you do have to worry about, just like you have software evolution, you do have to worry about, in traditional software engineering, here you do have to worry about smart contracts evolving. For the longest time, Fabric has supported that notion. So simultaneously, you could have different versions of the smart contract running because they don't bring the world to a silent mode state before they install a new version of a smart contract, but they ensure that for any given transaction, all the nodes will execute that transaction using the same version of the smart contract. So over time, slowly, then the old versions transactions will get out, and then you can, ignore any from that point onwards, any of the any old versions of that contract from coming into play. But they've done more things in version 2.0 to deal with this evolution. I have some comments about Libra, which got into a lot of trouble. This is a sort of a neither here nor there kind of system. It's got a core network, which is done by the members of the Libra Association, which is permissioned. But the fringe guys, the people who initiate transactions and so on, you and I kind of people, those are anonymous. So it's a mix of permissionless and permission, but they run into all sorts of issues. Even, Trump tweeted about how dumb an idea Libra is and so on. So originally they were going to have only their own currency, but March of this year, they decided, the last bullet, that they will also support fiat currency, but its future is still shaky, because even as they got into some of the discussions, many of the original people who said they would be part of it withdrew. But they claimed that this is not as bad as traditional cryptocurrencies. Kind of funny to say traditional, other cryptocurrencies, because they said this won't be subject to as much of speculation and so on, because this cryptocurrency Libra will be backed by some fiat currencies because of the money that the people who are members of the association pay. R3 Corda was started by a bunch of financial institutions. As a result, it built into the base system itself, the conceptual model, certain banking related things, in particular cash contract, bond contract, and things like that, which is different from the approach that the Fabric guys took, where they said, we'll give you a bare bones, but extensible way of doing things, where you can even plug in different ways of doing things, whether it's, what do you call it, these protocols, consensus protocols, and even database systems and so on. So each one has its own pluses and minuses, right? Then the financial guys built a system of their own, and they also do certain things like, this is a paper that was in VLDB. They have this notion that certain contracts and certain data can be public, anyone can see within a network, but certain contracts as well as data need to be handled in a more secretive way. So they talk about executing things in a highly secure way by making use of not just encryption, but also leveraging things like trusted execution environment like Intel SGX and things like that. Interesting stuff. Intel, talking of it, it introduced its own variation on blockchains by starting the so-called Sawtooth project under the Hyperledger umbrella. SAP guys said, hey, we want to be the good guys. We want to give you independence from, getting stuck with any one of these blockchain systems. So we will define our own API. That's what the central part is. And as long as you code to our API, this is like in traditional SAP R3, they have that BAPL or whatever it's called. As long as you code to that, you can willy-nilly change your mind about what backend blockchain system you want. In the case of SAP R3, you can use at one time Oracle, at another time replace that with DB2, and you don't have to change your SAP applications, because in the SAP application, you use some APIs that SAP provides, and then they translate from that to the underlying, in the case of R3, database system, whereas here, they say they'll translate to the underlying blockchain system like Fabric or multi-chain or whatever. But this is not providing access across these guys. You are using Fabric, so all calls got translated to Fabric APIs, and then you now replace that with multi-chain, then they'll, without your changing your smart contracts, make them go against multi-chain. That's all, okay? Anyway, there's all this stuff about smart contracts I already briefly mentioned. And then there is this DAML, which is trying to make your smart contract itself be portable, run on Besu, Fabric, Sawtooth, and so on. And then the integration across different blockchain platforms is this project, which is still in incubation, which is called Cactus, which was originally the work of Accenture and Fujitsu. They are trying to let you do these sorts of things. A single blockchain transaction could go muck around with things in multiple blockchain systems. And then just like you have Transaction Processing Council, which came up with benchmarks in the database space, a while ago, this project called Caliper was started in the Hyperledger Consortium to come up with similar sorts of benchmarks. Progress has been slow, but they've also come up with some tools for people to make use of. This is the project I was saying I was doing, where I wanted to replace the dumb get, put, delete interface with fancier things like select, insert, delete, update, even call, stored procedure, and so on. That's what the project was that I had to abandon because there wasn't enough resources that I got. In terms of futuristic thing, as I said at the very beginning, just like relational systems evolved, not only in terms of support for XML, object relational, triggers, this, that, referential constraints, and so on, they also evolved with respect to index advisor and partitioning advisor and auto ML and all that now more recently, right? You don't have to do anything. It'll figure out when to reorg the database and so on. There are many, many such things that one can work on. So my pleading to the community at large has been, instead of working on some esoteric stuff, there are enough things that are still to be worked on, make permissioned blockchain systems be more usable and all this kind of stuff that you might as well work on, which still have lots of interesting conceptual problems and all this. And even Silicon Valley guys or whoever entrepreneurial types amongst you can make money producing the kinds of goods that BMC Software and Platinum Technology and all these companies that were not hardcore database companies, but they were tool vendors sitting on top of database systems produced, and had a gala time over the decades in the database space. And then there is all this notion of how do I go from English language contracts, which determine multi-organizations working together, to a more formal looking thing. Like in the workflow space, people use Petri nets to model what's going on in a workflow environment in order to prove certain properties. Around here also, those sorts of things are possible, and IBM people were working on these things. And then you want to translate those conceptual models of what the smart contract is doing to actual executable code. There's a lot more things about, just like you have OLAP versus OLTP in traditional databases, even doing analytics on the blockchain data, there are various possibilities. Just like that world, the database community has evolved from separation between OLAP and OLTP to HTAP, hybrid transactional and analytic processing, where in the same database, you do both kinds of workloads so that the analytics will see the latest and greatest state. Such things are also very relevant in this context. And so there's no limit to, what all could be done. That's it. I believe this is the last slide, yeah.
All right, wonderful. Thank you so much.